Hi friends, welcome to my channel Olympiad Math. Today we are solving an interesting problem from algebra, which is an important segment of all highly competitive exams like GRE, GMAT, SAT, Olympiad, and so on and so forth. If you feel like you may give it a try first before looking at the solution I'm going to discuss here, and note your answers in the comments below. We are finding the value of this expression x to the power of 6, x to the power of 12, to the power of 18, all the way up to x to the power of 600. There are 100 terms. And there is an equation given to you, and that's to be used in finding the value of this expression. The given equation is x plus 1 over x equals minus square root of 3. So let's begin with the equation. Let me cube both sides of the equation. Raise to the power of 3, both sides of the equation. And this is what you get. X plus 1 by x, the whole to the power of 3 equals minus 3, the whole to the power of 3. We will use an algebraic identity like this. A plus b, the whole cubed equals a cubed plus b cubed plus 3ab multiplied by a plus b. This identity we use to expand the left side. Here a is equal to x and b is equal to 1 over x. So using that we get x cubed, then b cubed is 1 over x, the whole cubed, plus 3ab. A is x multiplied by 1 over x, this is ab, multiplied by a plus b, which is x plus 1 over x equals, this is the left side, and the right side, minus root 3 the whole cubed, which means minus root 3 multiplied by itself 3 times. Now this one is x cubed. This is actually 1 divided by x cubed. We are distributing the power 3 to the numerator and denominator. This, as you can see, x multiplied by 1 by x, these two will cancel out and you get 1. So that is just 3. Then instead of x plus 1 over x, let me write minus square root of 3. So this will be, I'm replacing this by its value, which is given to be minus root 3 in the given equation, nothing else, equals, then you're multiplying minus root 3. See, if you take the first two terms, minus into minus plus, root 3 into root 3, you get 3. Then there is this third minus root 3. I'm just writing it as it is. Look at this. There is 3 multiplied by minus root 3 here. Then there is 3 multiplied by minus root 3 here. They will cancel out. And you will get x cubed plus 1 over x cubed. Rather this taken to the right side, they will cancel out and you will get 0. Now what do? See, you multiply this equation throughout by x cubed. Multiplying, let me write it here. Multiplying throughout by x cubed, this equation, you get, let me write x cubed inside x cubed plus 1 over x cubed equal to right side 0 multiplied by x cubed. This implies we will distribute x cubed to each of the terms inside. So you have x cubed multiplied by x cubed plus x cubed multiplied by 1 over x cubed equals 0 into anything, we know 0. This implies x cubed multiplied by x cubed is x to the power of 6. This x cubed and this x cubed, they will cancel out and you get 1 equals 0. See, there is a law of index I used here. A to the power n multiplied by a to the power n equals a to the power of m plus n. That's what I have used here. See, x cubed multiplied by x cubed will be same base. You have 3 plus 3 and that's equal to, that's how I wrote x to the power of 6 for this one. This one cancels, you get So finally you get x to the power of 6 plus 1 equals 0. Now let me take 1 to the right side. You will have x to the power equals minus 1. This is an important result we have found out from the given equation, and this we will apply in the required expression to be evaluated. Now let me rewrite the expression given for evaluation, which is like this: x to the power of 6 plus x to the power of 12 plus x to the power of 18 plus x to the power of 24 goes all the way up to x to the power of 600. If you look at the powers of each of the terms here, you can see that it's a multiple of 6. So let me write each one as a multiple of 6 like this. 12 you can write as 6 multiplied by 2, 6 multiplied by 3. The fourth term, x to the power of 6 multiplied by 4. And the last term, x to the power of 6 multiplied by 100. In the next step, first term I will write as it is. Second term you can write this way: x to the power of 6, the whole to the power of 2 plus x to the power of 6, the whole to the power of 3. See, what will be the fourth term? I have not given here. If I write it here, it will be like this. And the last term will be x to the power of 6, the whole to the power of 100. There are 100 terms in the given expression, and I have made use of a simple law of index like a to the power of mn is a to the power of m, the whole to the power of n. See, for example, the second term, x to the power of 6 multiplied by 2. See, m is 6, n is 2. So you have x to the power of 6, the whole to the power of 2. That's how I have written this as this, and similarly the others. Now, we have found that x to the power of 6 is minus 1 here. Can you see this one? This we will substitute in this expression. So x to the power of 6 is minus 1. Next term will be minus 1, x to the power of 6, the whole squared. Third term inside minus 1, the whole to the power of 3. Fourth term minus 1, whole to the power of 4. And the last term minus 1, the whole to the power of 100. Basically, you have written all the 100 terms as minus 1 to the power of 1, 2, 3, 4 up to 100. Minus 1 I am writing as it is. What about this minus 1 to the power of 2? See, minus 1 to the power of even number is plus 1. So you will have plus 1. Minus 1 to the power of odd number is minus 1. Even number is plus 1. Minus 1. Like that it will go. And the last term is going to be minus 1 to the power of 100. 100 is an even number, so plus 1. Basically, you will be getting 50 minus 1s and 50 plus 1s. When you add minus 1 50 times, you get minus 50. When you add plus 1 50 times, you get plus 50. And finally, this is what you're going to get: minus 50 plus 50, which is 0. So the value of the required expression is 0. If you liked what you saw in the video, please hit the like button and subscribe to my channel. And whatever comments you have about the video, please do make it in the comment section. If you would like to watch other videos of mine, press the bell icon so as not to miss out any of my videos. Thanks for watching and see you in the next video.